Hello madam, today I'm going to do Izod impact test using a simulator. My name is Jo Fasina, daughter of Francis Drake, and my matrix number is 33DCE21F1074.
Hi ma'am, my name is Tanusha Sukumaran and my matrix number is 33 DCE 21F1025.
The objective of this is to find the impact resistance of mid steel and cast iron. The apparatus used is impact testing machine. Step 1. Select the Izod test specimen. I select mid steel. The length of mid steel is 75.7 mm, breadth is 9.54 mm, depth is 9.6 mm, depth of notch D is 4 mm. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. Loss of energy due to friction EF is 2 joule. Step 3. The Izod test specimen as per Indian standard IS 3766 to 1977 is placed in position. In trial 1, that has radius of curvature of striking edge, test piece, striking height, angle of up of striker, direction of impact, angle between underside of striker and face of test piece, and support. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. Total loss of the energy during transit of hammer E is 44 joule. Energy for failure of specimen is 42 joule. Trial 1's observation. Initial energy of the hammer is 164 joule. Average loss of energy due to the friction is 2 joule. Total loss of energy during transit of hammer is 44 joule. Energy for failure of specimen is 42 joule. For trial 2, step 3, the Izod test specimen as per Indian standard IS 3766 to 1977 is placed in position. Selected specimen is mid steel. Length 76.4 mm, breadth is 9.3 mm, depth is 9.16 mm, depth of notch is 2 mm. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. The test piece was not broken by stringing energy of the testing machine, so the impact value obtained is indefined. The observations of trial 2 is initial energy of the hammer is 164 joules. Average loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer indefined. Energy for failure of specimen is indefined. Trial 3, Step 3, the Izod test specimen as per Indian standard IS 3766 to 1977 is placed in position. Selected specimen is mid steel. Length is 77 mm, breadth is 9.52 mm, depth is 9.52 mm, depth of notch is 4 mm. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. Total loss of energy during transit of hammer is 46 joule. Energy for failure of specimen is 44 joule. Observation for trial 3. Initial energy of hammer is 164 joule. Average loss of energy due to the friction is 2 joule. Total loss of energy during the transit of hammer is 46 joule. Energy for failure of specimen is 44 joule. Total observation is for trial 1, loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 44 joule. Energy for failure of specimen is 42 joule. In trial 2, loss of energy due to friction is 2 joule. Total loss of energy during transfer of hammer is indefined. Energy for failure of specimen indefined. In trial 3, loss of energy due to friction is 2 joule. Total loss of energy during transfer of hammer is 46 joule. Energy for failure of specimen is 44 joule. Average energy for failure of specimen is 43.00 joule.
Today I would like to do Izod impact test. The objective is to find the impact resistance of milled steel and cast iron. The apparatus used is impact testing machine. Step 1. Select the Izod test specimen. I will select cast iron. The length is 76.4, breadth is 9.4, depth is 9.16 and depth of notch is 2. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the level without keeping the specimen. So the loss of energy due to friction is 2. Step 3. The Izod test specimen as per Indian standard IS is 3766 to 1977 is placed in position. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further. Then the observation is noted down. So the total loss of energy during transit of hammer is 5. Then the energy of failure of specimen is total energy minus by friction energy. So the answer will be 3. And the observations is initial energy of the hammer was 164 joule. Average loss of energy due to friction is 2. Total loss of energy during transit of hammer is 5. Energy for failure of specimen is 3. Step 3. The Izod test specimen as per Indian standard IS 3766 to 1977 is placed in position. Length is 75, breadth is 9.5, depth is 9.44 and lastly depth of notch D is 4. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further. Then the observation is noted down. The total loss of energy during transit of hammer was 6. Energy for failure of specimen was 4. Observation. Initial energy of the hammer is 164 joule. Average loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 6 joule. Energy for failure of specimen is 4 joule. Step 3. The Izod test specimen as per Indian standards IS 3766 to 1977 is placed in position. Length was 76.4, breadth was 9.4, depth is 9.16 and lastly depth of notch D is 2. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further. Then the observation is noted down. Total loss of energy during transit of hammer is 8 joule. Energy for failure of specimen is 6 joule. Observation. Trial 1. Loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 5 joule. Energy for failure of specimen is 3 joule. For trial 2, loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 6 joule and energy for failure of specimen is 4 joule. And for trial 3 is loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer is 8 joule and energy for failure of specimen is 6 joule. Average energy for failure of specimen is 4.33 joule. Thank you. That's from me.